Independent events. In this lesson, you will learn to find the probability of independent events. Before we do that, let's consider this example. While on a nature walk with their babysitter, Margarita and Billy collected acorns, walnuts, and stones. The table shows the contents of each of their bags. Suppose they each reach into their respective bag and randomly choose an object. What is the probability that Billy chooses an acorn and Margarita chooses a stone? And here you see a table of Billy and Margarita's bags, where Billy chooses six acorns and puts it in his bag, and he also was able to pick up eight walnuts and 10 stones, all in his bag. Margarita, on the other hand, has 12 acorns, 12 walnuts, and 16 stones in her bag. This is an example of what we call an independent event. Okay, the object that Billy chooses will not affect the object that Margarita chooses. And this is what we call an independent event. What is an independent event? An independent event, the definition of an independent event is as follows. Two events, A and B, are independent if the fact that A occurs does not affect the probability of B occurring. In other words, one event does not affect the probability of the second event happening. Okay? Some examples of independent events are landing on heads after tossing a coin and rolling a 5 on a single sided die. Both these events cannot affect the outcome of the other event. If you toss a coin, it will not affect the outcome when you roll a die. Another example, choosing a marble from a jar and landing heads after tossing a coin. Again, this event will not affect the outcome of, of this other event. Okay? Choosing three from a deck of cards, replacing it, meaning putting it back, and then choosing an ace as a second card. Once you put the card back, it becomes an independent event because now it will not affect the outcome when you choose an ace for the second card in the second event. Okay, rolling a four on a single six-sided die, and then rolling a one on the second roll of a die. Again, the roll on the second die will not be affected by the roll on the first die. They are two completely independent events, and those are some examples of independent events. And to work out independent events, the probability of two independent events A and B is the product of the probability of event A and the probability of event B. So to be able to find the probability of two independent events, you need to multiply the probability of A plus times the probability of B happening. Okay. Let's go back to Billy and Margarita's example. Okay. In that example, we were asked the question, okay, what is the probability that Billy chooses an acorn and Margarita chooses a stone? Okay, so let's go back to that example and let's answer that example. First, okay, the probability of choosing an acorn for Billy would be 6 over 24. Why 6 over 24? 6 will represent the number of ways Billy can choose an acorn, which is this number right over here. Okay? This number right over here. And 24 would be the number of possible outcomes because Billy has 6 plus 10 plus 8 things in his bag, which will equal 24. Okay, so it's 6 over 24, the probability of Billy choosing an acorn. Okay, on the other hand, let's look at Margarita and see what she has. The probability of Margarita choosing a stone would be 16 out of 40. Why 16 out of 40? Again, if you notice, 16 will represent the number of ways Margarita can choose a stone, which is this number right over here. Okay? And the number 40 will be the number of possible outcomes when you start adding 12 plus 16. That will give you 40. And that's how you got 40 right over here. So, what do we do next? Next thing we need to do is we need to multiply to find the probability. That means we need to multiply 6 over 24 times 16 over 40. We need to multiply 16 over 24. Okay. Six over 24 times 16 over 40. Okay. And if you notice, when you multiply these two, you can cross cancel 24 and 16. Cross cancel 24 and 16. The GCF of 24 and 16 will be 8. So 16 divided by 8 is 2. And 24 divided by 8 is 3. Okay. And the GCF of 6 and 40 is 2. So 6 divided by 2 is 3. And 40 divided by 2 is 20. To multiply the numerators and denominators directly, so you have 6 over 60. Or 1 over 10. So you can see from there, the probability that Billy chooses an acorn and Margarita chooses a stone is 1 over 10. The event is not too likely to occur. Okay. Let's look at example number 1 and let's find out. The number of cube is rolled and the spinner is shown is spun. Find the probability of rolling a 5 and landing on a consonant. So you have a die and a spinner. The reason why this is an independent event is because the outcome of the second event, which is spinning a spinner, will not affect the outcome or will not be affected by the outcome of the first event, which is rolling a die. So let's look at the probability of rolling 5 on a number cube. So the probability of rolling a 5, okay, will be equal to, there is only one number 5 on the number on the die and 6 possible outcomes, so it's 1 over 6. Okay, the probability of landing on a consonant, there are 3 consonants in this consonants in the spinner, so the probability of landing on a consonant, okay, will be equal to, since there are 3 consonants, B, C, and D, 3, and the total number of outcomes would be 4. Would be 3 over 4. Okay. Next thing we need to do is multiply our probabilities. So that would be 1 over 6 multiplied by 3 over 4. Okay. And cross canceling, that's a 1 and that is a 2. The probability of rolling a 5 and a consonant would be 1 over 8. Let's look at example number 2, life science. Owls lay two 5 rounded white eggs. Suppose an owl lays 2 eggs. What is the probability that the first egg hatched is a female owl and the second egg hatched is a male owl? Okay. We know for a fact from our genetic lesson, uh, the probability of a male and we know that how to get the probability of getting a male and a female of an offspring. Okay. In this case, you need to find the probability that the first egg hatched is a female owl and the second egg hatched is a male owl. The probability of getting a female owl is 1/2 because there are two only possibilities, male and female, and the probability of getting a male offspring will be 1/2 as well, 1/2. Okay, so if we do the math and if we get 1/2, okay, the probability of getting a female owl and multiply it with the probability of getting a male owl, which is also 1/2, the product would be 1/4. So the probability of getting a female owl and then a male owl is 1/4. Okay. We can check our answer by creating a tree diagram. And from our last lesson, okay, from our tree diagram, this is what's going to come out. We're going to have 4 possible outcomes, and we want to find the probability that the first one is female and the other offspring will be male. So it's female and male, which is going to be this offspring, which is 1/4. Okay, so our answer checks out. The next thing you need to do after this lesson would be to write a one-page summary in your own words, what the lesson is about, and explaining to me what independent events are all about and how to get the product of independent events. You also need to write down one question about this lesson. You may write it or you may type it. It's up to you. Okay. Thank you.